Hello and welcome. This is Ibrahim and I am back with another update for Europa Explorer. This time I am introducing the first segment of the home base, the science lab. This is where you can take the science samples you collect while you control the probe and then analyze them to learn more information and fill out the data archive. The first thing I want to talk about is the home base selection widget on the bottom left. This allows you to change between the different areas of the home base and is activated using the mouse wheel. Once more sections of the home base are available, you will be able to switch between them by holding Shift and using the mouse wheel. While viewing the science lab, the sample collection tray from the probe UI will be visible. Clicking on one of the samples will make it the active sample, and the active sample arm will come down and pick it up. If you click another sample, you simply get a warning that there's already an active sample. Clicking on the active sample will activate the test sample arm, which removes a small bit and places it onto the test tray. Each sample has a limited number of destructive tests that you will be able to perform before you simply run out of material to work with. The main part of this update is the actual experiments. My goal is for each of these tools to be similar in layout and functionality to the real devices, while still keeping this an interactive game experience with some kind of structured game system. Each tool visually represents its respective data collection with a similar set of meters, just that the rules for how each tool works can be very different. The first tool is the laser spectrometer. This works by firing a focused laser beam at the test sample and vaporizing it. The light coming off the sample then travels through a filter to remove the laser light, and then the light that is left hits the detector, which gives you some data. The laser generator has a power meter which drains when the laser is active and recharges when it is not. Holding spacebar fires the laser at the sample. You can hold down either mouse button and drag the mouse to adjust the angle of the mirror. The data you detect is relative to the point you fire at, which is different for each type of sample. The challenge is to find the right location to maximize the data collection, but you only get about 3 full duration laser shots before the sample is completely vaporized. The second tool is the Xray Spectrometer, which exposes the sample to a controlled source of radiation and then collects data by detecting the X-rays that come from the sample. This process is non-destructive to the sample. Pressing spacebar activates the tool, which is visualized by showing radiation particles traveling through these collimators and into the detector at the end. If you closely watch the particle stream, you may be able to see some particles that are out of place. Clicking on a collimator will activate it and remove any impure particles, but puts it on a cooldown. As the particle stream begins to hit the detector, the data meters will rise. Each impure particle that makes it through interferes with the data collection and lowers the data meter. The challenge is to remove as many impure particles as possible while dealing with the variable cooldowns on the collimators. The third tool is an Infared Microscope, which is also non-destructive to the sample. The light from the high-powered lamp is focused through a series of filtered mirrors through the sample and then terminated. Some of the light that passes through the sample scatters and makes it into the detector. Pressing spacebar activates the lamp, and you can adjust the spectrum of the light source by left or right clicking on each of the mirrors to cycle through the filter options. The resulting data collection is based on the filter combination compared to the sample, which will be different for each test sample. Each of the data meters also has an associated hint icon, which will help you decode the best combination of light filters. The challenge is to find the best combination to get the highest value possible on each of the data meters. The fourth tool is a mass spectrometer, which uses a high-powered laser to vaporize the sample and then stores it into compressed chambers. A generator powers the Analyser, which ionizes the particles as they pass through. The particles travel down this vacuum tube through this magnetic curve and impact the detector. If a particle is too heavy, then the magnetic force will not be able to prevent it from hitting the sidewall. Likewise, if the particle is too light. The particles that are successfully ionized have a better chance of making it through the detector. You activate the process by pressing space, and then pressing space again to release each of the chambers. The challenge is to time the release of each charge so that as many particles as possible get ionized and make it to the detector. The fifth tool is the gas chromatograph. The sample is again vaporized by a high-powered laser and carried into a chamber where it is mixed with helium, an inert gas that does not cause any kind of reaction. The gas mixture is pumped through a coil, heated, and passed through the detector. Pressing spacebar activates the tool cycle. You can left-click to raise the temp of each heat control, or right-click to lower it. The detector's data collection is driven by the final temp of the gas as it arrives at the detector. The vaporized particles in the gas sample have an effect on the specific heat and the heat capacity. Specific heat is how well the sample can retain the heat it carries, and heat capacity is a measure of how much energy is required to actually change the temperature of the sample. The challenge is to try to find the right temp settings on the 4 dials to get a good diverse data set at the end. The final tool is an organic molecule analyzer, which also begins by vaporizing the test sample with a high-powered laser. The particles are carried into a machine, sorted, and then injected into a sample chamber. The green molecules carry organic signatures and need to be sorted from the rest. You activate the machine and begin the process by pressing spacebar. You must try to click all of the green molecules to pull them over to the analysis chamber. When the timer on the vacuum pump expires, the test chamber is drained, and whatever molecules have made it to the analysis chamber are carried through to the detector and register some data. The challenge is to simply try and get all the molecules sorted before the time expires. You may have noticed that each time you run a test, there is a spectrograph pop-up, and then I remove the data description from the laser and X-ray spectrographs. Each one is generated from a specific set of traits based on the sample you are testing and how well you performed on that particular test. That specific spectrograph is saved as a data set, which then can be used again later on. The next thing I am going to build is another UI element which tracks which tests you have performed on the active sample and lets you finalize the data collection for the sample to store it in the archive. The finalized data set will include all the spectrographs and a block of descriptive text about the sample. To get this far with this update, I had to do a good bit of back-end work that you cannot see. Most of that involved transitioning scenes and splitting up the UI into modules and sharing the functions between the different layouts. So that pretty much does it for this update. There are a lot of rough edges to work out with this system, so I decided not to update the playable build this time around. I will be back again in 2 weeks with another update, and I should have a new playable build for you to check out at that time. Thank you for watching.